Good morning, one and all. Myself, T Shivanand H&S, Assistant Professor of Mathematics in H&S Department from TKR Engineering College. Today, my topic is Laplace transformation. A transformation is a mathematical operation which transforms a mathematical expression into the another equivalent simple form. That means any hard level to easy level you can express in a using these transformations. So it is a mathematical tool. Also, you can call that it's a mathematical tool. Example, we can take the logarithmic transformation. It converts the multiple division powers into the simple addition, subtraction, and multiple respectively. These so many transformations are there. The Laplace transformation is which has to solve the differential equation by using the algebraic method also. So we can use in a differential equation, solving the differential equation, we can use the Laplace transformation also. So Laplace transformation is a mathematical tool. You can call the Laplace transformation a mathematical tool, which can be used to solve many problems in science and engineering. So today I will explain the mathematical means Laplace transformation. So wait a second. Okay. So this is about the Laplace transformation. A transformation, just now only I repeated. Yes, this is a transformation. This is a mathematical operation also we can call, and a mathematical tool also we can call. It is nothing but you can use the mathematical expressions using hard level to simple level, hard level to simple level. So we can use this using this transformation. We can solve the differential equation also. So there is some different type of transformation also. There is a logarithmic transformation, which is just now and I explained, which is totally means division, multiplication, powers. We can easily simplification with addition, subtraction, and multiplication. So we can now will go for a Laplace transformation. So Laplace transformation here. So in a Laplace transformation, now see here. Definition of Laplace transformation. Let f of t be a function. Let f of t be a function in one variable. Let f of t be a function in a variable which is defined all positive values of t. Let s be a real constant if with the integral of integral 0 to infinity e power minus st f of t dt exist are equal to f of s. So the meaning is very clear. If we are integrating with respect to a t and e power minus st in the limits of 0 to infinity, then can call this one is a Laplace transformation. And the Laplace transformation is denoted as L of f of t. So Laplace transformation is denoted as L of f of t. So Laplace transformation you can call this one is L of f of t. Um, Now, Laplace transformation in a main, this Laplace transformation f of t is said to be existing if integral convergence for some value of s, otherwise it does not exist. Means the function is compulsory, it will be exist function. We can take it that f of t will be compulsory existing function. So here the operator capital L is called Laplace transformation operator, which transform the function f of t into the f of s. Means that is a limit s tends to infinity, f of s is equal to 0. So here is the Laplace transformation definition. So mainly the Laplace transformation, if we are applying for a Laplace transformation definition, we have some conditions. The first condition is piecewise continuous. Piecewise continuous. So here piecewise continuation means here the piecewise continuous. The piecewise continuous definition is a function f of t is said to be piecewise continuous in any interval of a comma b, closed interval a comma b, if it is defined on an interval, and the interval can be divided into the so many finite number of subinterval which is equal to means which are f of each which in the interval the function is continuous. Means if you are taking suppose interval a comma b. So we can subinterval A comma B into so many subintervals, so many finite number of subintervals. If you suppose we can take A plus lambda or B minus lambda or A plus 2 lambda, B minus 2 lambda, you can take it in the subinterval also. F of t is compulsory, it will be the continuous. Then you can say this one is a piecewise continuous. Means whenever you are applying for applying for a Laplace transformation, if the function must be a piecewise continuous. The graph will be like this. I will show the graph. So this is the graph. So this is a graph. F of t is continuous from alpha to beta. In from the closed interval alpha to beta, there are so many subpoints or means sub intervals are there. Alpha to t1 and t1 to t2, t2 to t3, and t3 to beta. So in these sub intervals, suppose you are taking alpha to theta 1. Alpha to theta 1 also it is a continuous, and theta 1 to theta 2 means T1 to theta 2 also it is a continuous, T2 to theta 3 it is also continuous. Means if you are subdivided in so many infinite number of sub intervals, in that function, in that intervals also the function is continuous. That is the meaning of piecewise continuous. And next exponential order. So these two conditions are necessary and sufficient for a whatever the problems you are applying for a Laplace transformation. First one is piecewise continuous, and the second one is exponential order. The exponential order is nothing but limit. This is a exponential order. Exponential order. This one limit t tends to infinity e power minus st into f of t is equal to 0. Whenever you are getting this one, you can call this one is a exponential order. Any function, if you are taking suppose any function you are applying for a Laplace transformation, that must be satisfied the piecewise continuous and exponential order. If the two conditions are satisfied, then only you can call that one. You can apply for a Laplace transformation. Otherwise, you can't apply for a Laplace transformation. So these are the two conditions, sufficient condition for a existing Laplace transformation. First condition is f of t is a piecewise continuous and sectionally continuous. We can call the piecewise continuous also sectionally continuous. And the second one is f of t should be a exponential order. If f of t, if in these two conditions, any one condition is failed, we cannot apply the Laplace transformation. Means the function is compulsory piecewise continuous and it must be a exponential order. If it is, if sometimes some functions will be, it must not be a exponential order, or sometimes it not be a piecewise continuous, then we can't apply for a Laplace transformation. And here some conditions are there. Here some conditions are there. We can call this one is a. We can call this one is a L'Hospital rule. Means we the function is does not exist. 7 undetermined undetermined solutions are there. 0 by 0 and infinity into infinity, 0 power 0 and infinity by infinity, 1 power infinity and 0 power 0 into infinity. So these are some indeterminate functions are there. So in this cases, we can use the exponential order. So here you have to apply the L'Hospital rule. We studied in a lower level of lower level classes. So L'Hospital rule, you can use the L'Hospital rule and you can solve these problems. Suppose f of t is equal to t square and f of t is equal to t power 8. So first one if we are applying the exponential order, limit t tends to infinity e power minus st f of t is equal to 0. This is the definition. So if you are applying for the t square, limit t tends to infinity e power minus st into t square. So here e power minus t, that is a negative. If you come to the denominator, it is a positive. So if you are applying the t in the place of t, it is a infinity, then it is the form of undetermined, infinity by infinity. So here you have to apply for a whenever you are getting the undetermined form is these 6 undetermined forms are there. Sorry, 7 undetermined forms are there. In undetermined form, simply you have to apply the L'Hospital rule. So L'Hospital rule means you have to apply for a numerator derivative by denominator derivative. So then you will get the finite value, means you will get the solution in a finite number. So here, if you are applying this for this one, so you are getting 2t by e power minus st into s. You got it. So this is again an undetermined form. Again, you have to apply the L-Hospital rule. So listen here. If you are getting first term undetermined form, then you have to apply the Laplace means L-Hospital rule. And after that also you are getting again undetermined form. Then again you have to go for a L-Hospital rule. Here limit t tends to infinity 2 by s square into e power st. So if you are applying the t tends to infinity, so it is e power 0, you will get totally. So this is a finite number. The answer is exponential order. Hence, if whenever you are getting the finite answer, the answer when you are getting the finite answer, whatever will be there, maybe it is 0 also. So then you can say it is a exponential order. In the second problem also e power t square. So we can use this one also same using this one also. So next Laplace transformation definition, we can use the Laplace transformation definition for L of e power minus 80. So L of e power minus 80 for Laplace transformation definition. Actually, the Laplace transformation definition is, uh, wait a second. So Laplace transformation definition is this one, the Laplace transformation definition. L of f of t is equal to integral 0 to infinity e power minus st into f of t into ds is equal to f of s. Means whatever the function f of t they given, you have to integrate with respect to t in the interval of 0 to infinity. So here the first problem is there. The first problem they are asking about to find the L of e power minus 80. So L of e power minus 80, you have to prove that this one is 1 by s plus a, where s plus a is greater than 0 and r s is greater than r minus a. So by the definition of Laplace transformation, L of f of t is equal to integral 0 to infinity e power minus st f of t dt. In the place of f of t, you have to apply f of t, you have to apply e power minus 80. So e power minus st is there already, and e power minus st is there, and e power minus 80. So here bases are equal, power should be added. Then e power 80 is nothing but integration of e power 80 is nothing but e power 80 by a. So we can do that one. So using this one, applying the lower limit and upper limit, you got it. You will get 1 by s plus a. So it is a one formula also you can take it. After doing these all things, L of a e power minus 80 is equal to 1 by s plus a. So we can in the further we can use it this one as a formula. So second problem is there. In the second problem, they given simply e power 80. So here e power 80 is there. Simply you have to substitute in the Laplace transformation definition f of t in the place of f of t. You have to take e power 80. So here also base are equal, power should be added. So power should be added means e power minus if you are taking common. So minus if you are taking the common. So you will get e power minus of s minus a into t into f of dt. So if you are doing that one e power 80, always e power 80 by a in integration the formula. So after that we can use this one upper limit minus lower limit. Again you will get the s minus a. So here you will get the converse means converse result, opposite reverse. If you are taking the first column e power minus 80, you got it 1 by s plus a. If you are taking a e power 80, you got it 1 by s minus a. So you have to remember these formulas for next upcoming problems for using these odd formulas. So now third problem is they are asking about to find the L of cos 80. Means here in the place of f of t, they given cos 80. So in the cos 80, so here they are using the formula of cos 80. So cos 80, you can use it f of e power minus st and cos 80. You know the formula of integral of e power 80 into cos 80. It is intermediate formula, this one. In intermediate, we have this formula. So e power minus st by s square plus a square. So minus s into cos 80 plus a into sin 80. Now the limits are 0 to infinity. So if you are applying the upper limit, the function totally will be 0. the function total will be 0, and the lower limit, if you are applying the lower limit, you'll get s by s square plus a square. So these are the formulas for using the for this solving this problem. A for ax into sin bx and e for ax into cos bx. So after this third problem, we'll go for a next. So fourth one also e power sin 80 they're asking. So similar way you have to use it the same formula. Here sin 80 whatever will be there e power st by a square plus b square a into sin bx minus b into cos bx. So here if you are using the you will get the upper limit minus lower limit, you will get a by s square plus a square. And after that one cos h80. Cos h80, you know that one cos h80 formula hyperbolic function. So it is a cos h80 formula is nothing but e power 80 plus e power minus 80 by 2. Alane sin h80 is nothing but e power 80 minus e power minus 80 by 2. So whenever you are getting the e power 80, you have to use the first form. So see here simply L of e power 80. So L of e power, suppose L of e power 80 is there. So L of e power 80 means the first formula is 1 by 8. You are getting a opposite. So if you are getting L of e power minus 80, you will get 1 by s plus a. If you are taking the L of e power 80, you will get 1 by s minus a. So here you have to apply that one. So 1 by s minus a plus 1 by s plus a. After that one, you have to do the LCM. So you will get s by s square minus a square. Means finally you got it. L of cos h80 is nothing but s by s square plus a square. Similarly, the next problem is also there. So sin h80. So hyperbole in the hyperbolic function, sin h80 function formula is 1 by 2 of L of e power 80 minus L e power minus 80. So here the formula is 1 by 2 again. You have to use the L of e power 80 formula 1 by s minus a. And e power minus 80 formula is also 1 by s plus a. After using this one, you will get a by s square minus s square. So here also you are getting cos h80 and sin h80 formulas. Cos h80 is nothing but s by s square minus a square, and sin h80 is nothing but a by s square minus a square. And after that one, L of 1. So this is the most important formula, L of 1. So in the function f of t, you have to substitute only f of 1. Ante f of t దగ్గర you have to substitute only 1. So if you are substituting f of 1, means f of t place in the place of f of t, you are substituting f of 1 means 1. So you will get integral 0 to infinity e power minus st. So whenever you are getting e power minus st means e power minus st by s. So upper limit is infinity, lower limit is 0. If you are substituting, you will get 1 by s. So this 7, and after that 8th one also t power n. So you are applying for a t power n. So you will get this one is in different type of forms. So integral 0 to infinity e power minus st into t power n dt. So you are applying the pi parts formula, that is nothing but UV method. Integral of UV method, you have to use it. So integration of UV method, it is a pi parts method. So you have to use it. First one is t power n is u, you have to take it, and the second one e power minus st is always you have to take the p. So it is within the continue until the you get the answer. So the total answer will be like this. Total answer will be n factorial by s power n plus 1, or you can talk it gamma of n plus 1 by s power n plus 1. Means the t power n, the formula of L of t power n is equal to n factorial by s power n plus 1, or gamma of n plus 1 by n s power n plus 1. Okay. And next L of some linear properties are there. For these linear properties, we have the addition, subtraction, and multiplication with constant. So addition. So here the problem is L of f of t plus or minus g of t. So L of f of t, you can split it. It means Laplace transformation of two functions, addition or subtraction. So we can divide into the two different parts. One is the Laplace function of f of t, and one is the Laplace function of a g of t. Here also they are showing the same thing. And the next one is a constant multiplication. L of k into f of t is nothing but k into L of f of t. So these are the linear properties. Means using this one linear properties, we can do the different type of problems. And the next one is these are the formulas, whatever the formulas, the trigonometry formulas we are using here, Laplace transformation. These are the lower level formulas are there. So these are the problems. So starting with the problem with sin square t. So in the sin square t, how to find the Laplace transformation of sin square t? So first of all, there is no formula, official formula. So sin square, cos square, there is no formulas are there. So first of all, you have to split it into the sin square t into the 1 minus cos 2 theta by t. So in this one, 1 by 2 is the denominator is a constant. You can remove that one. So you can write into the front, and after that L of 1 minus cos 2t. So L of 1 already you know that one is 1 by s, L of cos 2t. So just now only we wrote that one cos 80 also we did. So see here cos 80 is nothing but s by s square plus s square. So here also we have to do the same thing here. S by s square plus. In the place of a, you have the 2. So s by s square plus 4. Similarly, the next second problem also there. L of cos cube t means cos power 3t. So just now only I explained there is no official formulas for cos square t, sin square t, cos cube dt, and sin cube dt. Because only sin 80 is there, cos 80 is there, and sin h80 is there, cos h80 is there. There is no official formulas for, there is no formulas for sin cube, cos square, sin square is there. So first of all, you have to split it to the trigonometry using the trigonometry function. So you have to find the cos 80 formula. Cos 3a, cos cube t, you can use in cos 3a. So the cos 3a formula is nothing but 4 cos cube a minus 3 cos a. So in this one, in this one, you can find out the cos cube t formula. So that is nothing but 3 by 4 into cos a plus 1 by 4 into cos 3a. So here, here cos cube t is equal to 1 by 4 of L of 3 cos t plus cos 3t. So just now only we discussed about the cos t formula, that is nothing but L of 3 cos t minus L of 3 cos t is nothing but L of 3 into s by s square plus 1 square. In the place of a, you have 1. And cos 3t also s by s square plus a square, that is nothing but s by s square plus 1. After coming to the third problem, there is a problem L of sin 3t into cos 3t. So here also there is no formula for a two trigonometric function multiplication also. So here you have to use the you have to use the trigonometric formulas like cos sin 80, 2 sin a cos b, 2 cos a sin b, 2 cos a sin b, and 2 cos a cos b, and 2 sin a cos sin b. So here you will get the formula. So like that only. So here there is no 2. So first of all, 2 by 2 you have to multiply. Then you will get 2 sin a cos b is there. So when you are getting that 2 sin a cos b is nothing but sin of a plus b plus sin of a minus b. So here sin of a plus b, a plus sin of a minus b, you have to apply the formula. Then you will get 1 by 2 of sin 4t plus sin 2t. So when you are applying the Laplace transformation, 1 by 2 of L of sin 4t plus sin 2t. So just now only we discussed about the sin 80 formula. So this is nothing but a by s square plus a square. So 4 by s square plus in the place of a you have 4. So s by s square plus that is nothing but a by 4 by s square plus 60. And after that one sin 2t also 2 by s square plus 4. So finally we got the result. In the denominator we have the 2 denominator. So we can cancel this one. And finally we'll get the result. 4 by s square means 2 by s square plus 16 plus 1 by s square plus 4. So after that one, we'll go for another formula, another problem, sorry. Fourth one, L of sin t, sin 2t, sin 3t. So here there are the 3 functions are there, sin A, sin B, sin C. So in the trigonometric function also, we don't have the sin A, sin B, sin C. We have the formula for sin A, sin B, cos A, cos B. So there you have to take it only 2 functions first, sin 2t and sin 3t. So sin 2t and sin 3t, the formula is 1 by 2 of cos A minus B minus cos of A plus B. That is nothing but 1 by 2 of cos t minus cos phi t. And after this one, whatever you are getting result, you have to multiply it to sin t. So then you can apply the sin t into cos t and sin t into cos t. So you will get two sin a into cos a is nothing but sin 2a. And after that, sin t into cos t nothing but sin of a plus b, sin of minus sin of a minus b. So after you have simplified this one, you will get 1 by 4 of L of sin 2t plus sin 4t minus sin 6t. So simply you have to apply the formula. So sin 2t is nothing but a by s square plus a square. And here all are sine functions only. So here also a by s square plus a square, you will get a by s square plus a square, you will get. So that is nothing but 2 by s square plus square and 4 by s square plus 16 minus 6 by s square plus 36. And coming to the next problem, fifth one. So they're asking about to find the L of 1 plus e power minus 3t minus 5 into e power 4t. So here the three functions are there. First, you have to split it. The linear property you have to apply. The linear property is just now only we discussed. The linear property is saying nothing but if the addition is there, Laplace of addition or subtraction is there, you can split it to the two parts, two functions. Suppose f of t and g of t are there. Here the first linear property. So we can split it. Similar to the problem also same like that one. So here the three functions are there. F of t, you can assume that one is f of t, first one, and second one is g of t, and the third one is h of t, you can take it. So L of 1 is nothing but 1, and L of e power minus 3t is nothing but you can take it g of t, and 5 into e power 4t is nothing but you can take it, that is h of t. Means separately you have to split it. L of 1 plus L of e power minus 30 minus 5 into L of e power 40. You can apply the formulas, you will get 1 by s plus 1 by s plus 3 minus 5 by s minus 4. Like this, you can do it all the different problems using the basic problems, using the Laplace transformation linear properties. When you using the trigonometry functions and linear properties, the basic problems you can complete it. So here the one more problem is there, 6-1. There is 1, 2, 3, 4. Four functions are there. You can use the linear property. Means here L of f of t and g of t, h of t, and you can take it j of t. Means each and every time they have to use the linear property, you have to split it. Laplace of 3, Laplace of e power 60, Laplace of sin 2t, and Laplace of 5 into cos t. You have to apply this one, and you can do the LCM for the answer. So here also one more problem is there, sin of 2t plus 3. So we don't have the formula for sin a plus b or sin ax plus b in a Laplace. So we have to split it compulsory using the trigonometric formula. So that is nothing but sin a cos, means sin a plus b. Sin a plus b is nothing but sin a cos b plus cos a sin b. So if you are using this one, you will get cos 3 and sin 3. So these are the constant. In the second linear property, I will show you the second linear property. In the second linear property, if k is a constant, k into L of f of t is nothing but k into k you have to take outside, and the constant we can't apply any Laplace transformation. So k into whatever the L of f of t. So here also the same thing. Cos 3 and sin 3 both are the constant. After that one, whatever the remaining, you have to apply the Laplace transformation. So cos 3 into L of sin 2t, and similarly sin 3 into L of cos 2t. So after this one, we have one more problem is there. Here also 1, 2, 3, 4 formulas are. These 4, f of t, g of t, h of t, and j of t. So here also you have to use the linear property only. You have to first whatever the functions are there, you have to split it, and after that one, so we can get the result using this form. And the next one also here, power is there. Now listen here, there is only one problem, one formula is there, L of t power n is there. Where it is, I will show you. Only this formula is there. So L of t power n is there. So n factorial by s power n plus 1 or n plus 1 factorial by s power n plus 1. But here, one function is there, not like that one, independent of t power n. It is 1 plus t square. So first of all, you have to split it. So L of a plus b whole square means 1 plus t whole square is, you can split it. a square plus 2a square plus b square plus 2ab. So here also 1 plus 2t plus t square. So L of 1 plus L of 2t plus L of t square. For that L of 1, we will get 1 by s square. And L of 2t is nothing but where 2 is a constant. So 1 of s square and L of t cube is nothing but t 2 factored by s cube. And here one problem is the discontinuous problem. So here you have to remember one thing you have to remember. The starting only apply, I said that one whenever you are applying the Laplace transformation, the two functions, two conditions must be satisfied. The two conditions are nothing but first one is f of t is a piecewise continuous function. Means if you cut it in the interval a comma b, then the finite number of subintervals also the function must be continuous. And the second one is f of t should be a exponential order. F of t should be a exponential order. So these two conditions must be satisfied. So here the function is there. In the function the given that one is a discontinuous formula. Okay. Now see here, they're asking about the sine t. The sine t is valued from 0 to pi only. And after that, the value will be 0 if t greater than if t is greater than pi. So you have to take 0 to infinity in from so here very important. So the limits is 0 to infinity. So 0 to infinity you can split it to 0 to pi, and after that pi to infinity you can take it pi to infinity, and then you can take pi to infinity. So 0 to pi, you can take it in that function. The function is sine t, and here the function is 0. Here the function is 0. Here the function is sine t. So we'll get that one. So like this, you can apply this one. So whenever they're given the discontinuous formula, you can use it in a valid function. So here the valid function is nothing but in the interval of 0 to pi only. So 0 to pi e power minus st into sine t. So the function in this one, the value will be 0 because the function is does not exist to be a greater than pi value. So here only e power minus st into sine t. So again, this is a trigonometric formula. Means in the integration formulas are there. So sine AT into cos BT are the formula is nothing but you will see here sine AX into e power AX into sine BX. In this one formula is e power AX by A square plus B square into A sine BX minus B cos BX. Upper limit is in pi and lower limit is 0. So you can use it, you can get e power minus 2s plus 1 by s square plus. So these are the discontinuous. One more discontinuous formula is there. Means whenever you are getting the discontinuous means whenever you are getting the means discontinuous problems. So we have to check it whether where is the function is continuous. So the function, if the function is continuous in the limit of 0 to 1, you can take it 0 to 1 only. So more than 1 it is 0, you can consider that. So in this problem also we can do it like the integration 0 to infinity e power minus st f of t into dt. So here also f of t can consider e power t only because the function is valid from 0 to 1 only. So here also integral you can take it integral is 0 to infinity. You can split into the 0 to 1 and 1 to infinity. It's the function wherever the function is valid, there only you have to apply this one. Okay. Now see here we are applying the e power minus st, and 0 to 1 the function is e power t. So there are bases are e power should be added. So you will get e power minus. You will get e power 1 minus s of t. So 1 by s minus a means you will get e power 8 integration of e power 8 formula is nothing but e power 80 by a. So here upper limit to lower limit if you substitute, you will get the answer 1 by s 1 minus s into e power 1 minus s minus 1. And after these basic problems, we have some different type of problems. That is nothing but like this for 12th one. So here it is nothing but L up to 1 by root t plus t power 1 by 2. So t power 3 by 2. So it is a fraction. In the power, it is a fraction. So Laplace transformation is defined whenever you are getting the number, not for a fraction. So suppose here L of e power minus t power minus 1 by 2. So t power minus 1 by 2 formula is different whenever getting the fraction. So when you are getting the fraction, you have to take one more formula is there. Just only we discussed that one. So this is the form. So if you're getting the fraction gamma of n plus 1 by s power n plus 1. If it is a nothing but it is a number, you can take it n factorial by s power n plus 1. So here it is a fraction is there. So where it is problem 12th one. Here it is a fraction is there. So gamma of n plus 1 by s power n plus 1. So gamma of minus 1 by 2 plus 1 by s power minus 1 by 2 plus 1 and plus gamma of 3 by 2 plus 1 by s power 3 by 2 minus 1. So you can apply that one and gamma of 1 by 2 by s power 1 by 2 plus 3 by 2 of gamma of 1 by 2 s power 5 by 2. So gamma of 1 by 2 we know that one root 5. So s power 1 by 2 can be written as root s also plus 3 by 4 root 5 is also 3 by 2 into 1 by 2 3 by 4 and gamma of 1 by 2 is nothing but root 5 and s power 5 by 2. So these are the basic problems. Basically using the linear properties and trigonometric functions using the basic problems of Laplace transformation. So after this one, we have the main topics that the first shifting theorem and second shifting theorem, change of scale property and multiplication by t, division by t, and the derivatives, integrals, everything is there. So here the main concept. So the main concept is whatever the integration we are while doing the integration, we are facing the many problems. Some different functions we can't do the integration higher order. So for that one, you can use this Laplace transformation. It is main use for Laplace transformation in nothing but it is a mathematical tool. It is expression of another equivalent and simple form. So this is our topic today topic Laplace transformation. Once again, I will repeat that one. First one is Laplace transformation, where you have to use this one is you can use in science and technology because with integration problems we can't do in a proper way. So using the Laplace transformation, you will get the very simple way. And after that one, whatever the values, very, very important. This one here it is. Whenever you are applying the Laplace transformation, there must be a necessary and sufficient condition. There must be two conditions must be satisfied. The first condition is piecewise continuous, and the second one is exponential order. If it is satisfied the two condition, then only you have to apply the Laplace transformation. So this is the today topic. I hope all of you understood this one. Thank you very much.